All good streams start with some lo-fi. Okay, we're live, and we have 4 people in the audience so far. Welcome, everyone. Welcome to the stream.
Hello.
All right, people start filtering in. There's a few UIs I have to get logged into. Dude, I tried to get my Chrome extension that blurs sensitive stuff. It's not working.
Oh, no, it was so good.
I know. I'm super bummed about that.
Yeah. Was there like an update to Chrome itself that crashed it, or maybe an update?
No, I moved stuff over to my personal laptop, so I don't know. Maybe I broke it. All right. We got Mehmet in the chat.
Hey, Mehmet.
Dude, Mehmet, I met a friend of yours. His name's Halil.
Oh, yeah.
But he doesn't know Mert. You do know Mert. So the Turkish connection, it's missing at least one link. All right, let's do this. Let's get started with this. Everybody, welcome to the stream. Welcome to Office Hours. Here in Office Hours, you can ask us questions on anything you want in the chat. There's like a 30-second to 1-minute delay. So when you ask us questions, don't be offended if it takes us at least 60 seconds to start acknowledging what you said. We are going to be doing these Office Hours with a topic. So during the stream for the next 90 minutes to 2 hours, we're going to be talking about Iceberg and AWS Glue Catalog and DuckDB. Possibly killing databricks. We'll see. We'll see if you can kill databricks with that. It's okay, though, if your questions are completely off topic. I don't know. We can decide if your questions naturally fit into the discussion or not. I'm just now seeing a message from Mehmet. His name is Halil. Did I say it wrong? I'm just kidding. So yeah, so ask those questions on any topic, and we'll try to answer them. So the content of the stream is more of a backdrop to have something interesting to talk about in between questions. All right, let's do this. Let's talk about Iceberg and DuckDB and Glue Catalog.
Yeah.
I will share my screen. Also, this is Hassam. Do I introduce Hassam?
Yeah, I'm a senior engineer at Ernst & Young. I'll also be leading the next cohort of our course, MLOpsclub.org. It's somewhere in the description, maybe. But yeah. Oh, there you go.
I can flash it on screen so you know what you're talking about.
Oh, yeah. There you go. Huge QR code.
Come join us. Come learn about AWS. It'll be great.
Yeah, server. Maybe we'll share that as well. Come hang out and
Sweet.
Yeah, talk about all things MLOps.
Sweet. Okay, I'm pulling up a diagram tool to kick us off here. Let's see. All right, so let me frame what we're trying to do today, because many people are unfamiliar with what's going on in the open table format world with data lakehouses on S3 and blob storage and all that. So let's frame the discussion. Okay. Sorry, actually, I'm new to this streaming software, so 1 second.
It shared for a second.
It did. It just didn't share the way I wanted to share it. Okay.
Okay. There you go.
All right. We might get Demetrios showing up from MLOps community on the stream too. I hope he comes. Okay. And let me just can I get this out of the way? There, that's better. All right. Okay. We're going to talk about data lakehouses for a second. So if you've heard of Snowflake, and they just had the Snowflake Summit like last week or 2 weeks ago, and Databricks is having their summit next week, which are these massive events that everyone comes to, and they basically listen to paid ads for 3 days straight. So those tools you can think of them as massive databases. If you're doing data science, machine learning, or just regular analytics, you usually use a kind of database that can handle a lot of data, because when you're doing analytics for a report on a company, you're often looking like far back in history, summarizing like years worth of data or many months worth of data to give some sort of insight. So regular databases, like transactional databases like Postgres and MySQL, those databases are transactional databases. They're not they can handle a large amount of data, but they're not necessarily optimized for queries that do calculations on a large amount of data. Like these databases like Postgres and such, they're optimized for working on one row at a time or a few rows at a time and doing lots of joins. Yeah. Whereas in reverse, in the analytics world, you do almost all your queries are looking over like these long spans of historical data. So fundamentally, they serve different purposes. You'll see a transactional database in a credit application, and you shouldn't see a transactional database usually for an analytics use case. So usually companies will have both. They'll have transactional databases like Postgres for their credit apps, and they'll have a data lakehouse, like this big database for all their historical data. And in this scenario, they don't care if their queries take a couple of seconds to run. Whereas if you have an app, you want it to be fast.
Yeah.
Cool. I'll put some terms on
Yeah,
the
there you
screen
go.
here.
I think of it as well in terms of like structured and unstructured. I know maybe that's a bit too like strict to think about it, but like structured data, like purely transactional as well, lives in like the database and like data warehouse land. And then unstructured data for analytics of like last 20-year financial years, like fiscal years, and we want, I don't know, the something to do with like profits or revenue, and a lot of random queries that like whoever created the database did not anticipate and optimize the structure for. That's like data lake or data lakehouse land. And yeah, OLTP and OLAP, exactly.
Nice.
So
And I
yeah,
would clarify. I wouldn't say the difference is like one is structured data and one is unstructured data. Like
yeah,
they're
that's
both
true.
equally bad at unstructured data.
Yeah.
I don't know. Postgres has PG vector, so it can directly do vector
Yeah,
operations. I
that's
don't
true.
know if Snowflake and Databricks have a vector type, actually. I feel like I should know that. Anyway, but yeah, but generally, like the technology is most mature in all of these things for anything you can represent as a spreadsheet and not like text
Yeah,
or images.
that's true.
Okay, so Snowflake and Databricks, great tools, super powerful, can be very expensive. Can be like the starting cost can be fairly high, like higher than $5 for a project.
Yeah.
So you're probably using these tools. You're probably only using these tools if you have a business and an enterprise subscription to them. That doesn't mean that what we're going to show you today couldn't be used for enterprise. I would actually argue that it absolutely could. What we're going to show you today is the starting cost is actually zero because it'll be completely serverless. Anyway, so just talking about the history of what these do for a second. So with Snowflake and Databricks, the way we're going to talk about them today, you can essentially think of them as a gigantic database, terabytes, petabytes of data. And they're all represented as tables. And you can do SQL queries in these things. You can do joins, you can do transformations, you can do window functions, all these things. And you can use those SQL queries to create training sets for models or prepare sets for inference for models or to write inferences, store inferences in those tables. Let's see, what was the other thing I was going to say? So yeah, models, and then also analytics. If you're just trying to count like the number of sales the number of projected sales or the number of like current sales in the last few quarters, you would power that generally with a SQL query in one of these guys as well. Okay. So we're talking about, so is there a way that you could do those same use cases, have lots of data and do SQL queries on this data? And you don't necessarily care if the SQL queries take a couple of seconds to get back to you. Is there a way that we can handle that use case more simply than getting a contract with one of these guys or going through the heavy install process? That's where DuckDB enters the picture and also Iceberg. So unfortunately, I would say DuckDB has some limitations with Iceberg that we'll talk about today. But so there's been this movement basically that used to be that if you bought one of these tools, your data would be completely locked in to one of these. So let's say I'm tracking my sales data for history. Oh, did we just get Demetrius? Yeah, nice. Dude, welcome to the stream.
What's up, guys? This is awesome.
Hello.
Dude, what's new with you, Demetrius?
I am very curious about what you all are talking about, so I figured I'd just jump on real fast.
Very cool. And I'm assuming that you have some context about what Iceberg is in DuckDB, right?
Yes.
Sweet.
Don't ask me to explain it, though.
Yeah.
That's your job.
We already tried. Hopefully we succeeded, but
Good.
So I'm trying to paint Snowflake and Databricks as like the bad guy right now, and that DuckDB, the champion, is going to make it so we can kill them both.
Yeah, David and Goliath.
So like the TLDR of this, there's a history of lock-in here. It used to be that databases like Postgres and MySQL, these transactional databases, were like the only databases that existed. Maybe there were analytical versions of this, but essentially these were like these servers that you had to pay for. And let's say this square is your data, and then this square is like some CPUs that are used to process queries against your data. So like this is compute, and then this is storage. Let's see. It used to be that compute and storage were like tied up together. Like you'd put them both on one server, and this would be like a server hosting your Postgres instance or something. And usually what happens is your storage grows and grows, and maybe grows too big to fit on disk in this one server that you're paying for. But the only way to like up the disk size is it ends up being to pay for more resources on the server itself. And even though you didn't need more compute, what you needed was more storage. You end up having to pay for like bigger box sizes because your storage costs went up. Postgres and MySQL are fantastic, but not necessarily for large data. And with analytical use cases, like the whole point is to work on larger data sets. So in the analytical world, they were like, actually what we could do is we could separate storage and compute. So here, let's see, let me just drag this out. So we could have storage and compute be on like separate boxes now. So the storage could live somewhere like S3, or I don't know, in some file servers that are dedicated to just storage. And then compute could live on one server or multiple servers. If you use Spark, you submit a Spark job and it's like coordinating across a lot of nodes. So if you can separate these things so you don't have to have these co-located on the same box, then now you can scale up storage as much as you want. And you can scale compute down to 0 if you don't need it. If you're not running any queries, you can just turn off, like basically provision compute exactly when you need it, which is when you're running a query. And then, cool. So decoupling these things, that was one of the big value props of these two tools. It still is one of the big value props of these two tools. But there was still a bit of lock-in. So you were no longer locked into like the cloud that was hosting your server. Oh, so like a great example, I don't know if you could call Oracle DB a transactional database. Like it probably is also an analytical database, but like the big and the evil Oracle, there's so many enterprises that would like pay for these gigantic Oracle subscriptions, just fork over a lot of money to a vendor where all their data is locked into storage and compute. And these two guys come out and they're directly challenging Oracle because they have this new model. But the data world would say there was still some lock-in here. And the lock-in was that your data is still in a proprietary format. So if you're inserting all your data into like Snowflake format, or you're inserting all your data into Databricks format, then let's say you have a contract with one of these guys and you want to leave, or let's say a fancy tool like Trino comes out and you want to try using Trino to query your data, or DuckDB. You want to use DuckDB to query your data. In theory, if your data is like tied up in this proprietary format, the only thing that can query your data is like whichever of these two things you use. Enter open table formats. Okay, open table format. So the big two are Iceberg. I don't know if you capitalized the B or not. And Delta Lake. I think it was actually Databricks that championed this idea. I don't know the full history. So in my mind, they were the first ones on the scene with these formats, but I don't know, maybe they weren't.
I think so.
Okay, let's just hope that's true. But if someone wants to correct me in the chat, that's fine. But okay, so Databricks comes out with this file format called Delta Lake. And their whole thing is we will have an open source file format and you'll store your data directly on blob storage. Like you can put it in S3, you can put it on MinIO, you can put it in Cloudflare R1, which is, by the way, half the cost of S3 and doesn't charge you for data egress. So that's actually a great service. Anyway, you can stick these files on any blob storage that you want. And then now anything that can read from blob storage and write to blob storage can theoretically read and write from your data here. So like you could say that maybe Databricks with Spark is one way that you run SQL queries to read and write data in your files in Delta Lake. But you could also use anything else that's capable of reading and writing from these files. So like DuckDB is capable from reading from Delta Lake. DuckDB is this cool like Python. I think it's written in C++, and you can use like Python bindings for it. So suddenly maybe you can skip Spark and directly in Python, you could potentially query your data with SQL queries directly from wherever they're sitting. Yeah, and Iceberg is another format that tries to do the same thing. Like idea, if we start representing our data as these open file formats, then suddenly we're not so tied to these guys as our only compute engine. So do you guys want to add anything?
No.
I was going to ask about the rise. That's like the rise of the open table formats, but then there's also the rise of the DuckDB of the world. And
True.
If you know anything about that.
Okay, I listened to their announcement for Duck Lake, so I feel like that makes me an expert. I'm just kidding. But yeah, in their podcast where they announced Duck Lake, which is this new format that is mostly Iceberg, but not. Wow, we actually should totally talk about that. Okay, so this is great because this goes in a discussion of Duck Lake and DuckDB will help you understand how Iceberg works, which will launch us right into this demo we're going to do where we do this on AWS. So I would say this is a totally worthy detour. So like for the longest time, data people had CSV files. So this block is a CSV file. And CSV files they make a lot of sense. Like you can store a bunch of rows in them because that's what they're for. You can store data in these CSV files. And I think that's intuitive for humans because you can open this up and you can see the data in it. But it has a lot of downsides. Like these CSV files, they are plain text, so they're not compressed. So if you have a bunch of like spreadsheet looking data and you want to store it somewhere, it's more expensive to store it in CSV than say a compressed format. And I guess you could compress CSV files, but there's potentially even more you could get. There's even more you could get from a storage format than if you just use compressed CSVs. So Parquet in my mind, it's essentially like CSVs for data engineers. Like it's a file format, does the same thing. It's it stores columnar data. So CSV would actually represent all your rows literally as rows. Like it'd be value 1, comma, value 2, comma, value 3. If it's a table of people and the columns are name and age, then you would see literal rows here, like Eric 27, Demetrius, whatever, Hassan, whatever. And it turns out that it's potentially a better idea if you represent your data as columns instead. So it'd be like name, Eric, Hassan, Demetrius, age, 27, whatever. The reason that this is because a lot of the times, if you're running a SQL query and you're trying to do a query on historical data, tell me the median response time that we had in our support channel over the last year. That query basically needs to pull up all the response times in the last year and calculate the median. So it would be inefficient if those response times were buried in these different rows, because these rows aren't co-located next to each other in memory. So you'd have to go grab a value out of this row, then grab a value out of this row, then grab a value out of this row in order to do that query. Whereas if you store it in columns, you can just, exactly where the column is, and you just go grab that column in one go and then do the calculation. So yeah, like literally storing the bytes in memory as columns instead of as rows makes it faster to access data for analytical workloads. And I think this is one of the reasons why queries that analytical folks will write it'll give application developers nightmares, because like they're doing these massive queries over multiple rows and oh my gosh, that's going to tie up our database for an hour, lock out all of our customers. So it's just funny because sorry, go ahead.
Costs a lot of money.
Yeah, and then the reverse is also true. It's like the analytics people will be like, why are you doing a query, like this entire expensive join just to update one row? Don't you realize like what it costs, like the overhead of the infrastructure? Anyway, so it's just funny. Like these are two completely different worlds, and this is the world where the application developers live, and this is the world where the analytics people live. So this is Parquet. So Parquet, like Parquet has some other things too. Like it has this concept of pages. So here's a chunk, like this could be page 1, the first 100 rows or something for these columns, and this could be page 2. So anyway, it's like there's more going on in this file format, but it's got a couple of things. It represents the data as like actual columns, and it has types too. So you can literally say name is a string, age is is it a big int or something? Like they have more precise types than just integer. So this is pretty cool. Like programmers
Lance file format.
I've seen it and played with it, but I don't know what's inside.
Yeah, I have just heard that it's way faster than Parquet and not as finicky, because I think people get a little bit. Yeah, sometimes with Parquet you can have headaches. There was a really good write-up on basically the nuances of Parquet by the guys at I'll try and find it and drop it in the chat. But yeah, Evolution Compute, what was their name? I like see it in my head. I'll look for it while you're explaining stuff, but don't let me derail this.
The whole point is to be derailed. So also, are we watching chat? Does anyone have any questions so far? Let's see.
I am. No questions now.
All right. Sick. All right. Let's see. What we're doing here. So Parquet is columns. It also has types. It's also compressed. So those are 3 good properties of Parquet files. There have been proposals for a myriad of different file formats, even after Parquet, that purport to be optimized in some way or another. But if we moved to a different file format, it's like the meme where it's like, why is there no standard? Let's go make another standard. Now there's 14 standards. Like the whole value, one of the biggest value props of Parquet is that it's become a standard. Like lots of languages have libraries that can read and write to Parquet. And if you buy a vendor, chances are they can read and write to Parquet, because this is like the standard accepted data format for data engineers now. So that's something to note. Anyway, so what is Iceberg and what are Delta Lake then? So I know more about Iceberg than I do about Delta Lake, but they both fundamentally do the same thing. There was this tool called Hive back in the 2010s and earlier. And like these Hive people, they had this idea that they could represent their entire data lakehouse, or like they could represent all this tabular data at scale as files. So I think Hive gets the credit for being the first to like successfully launch a big open source product where like data engineers could treat their files as a database. So you could store your data in files, you'd put them on these Hive servers that would be on-prem, and then you could use MapReduce to basically do calculations on this data. Yeah. And Hive had a number of weaknesses that I don't know, it's not really worth talking about, but I think Hive was when like the mind of developers or like data engineers globally adopted this idea that like our data can just be files. We can just query the files instead, and that could be a way that we separate storage and compute, which is cool. Yeah. But I think Hive I could be wrong about this. I think that Hive was not ACID compliant, or maybe it only had portions of it, but ACID is this acronym. I don't know if I remember all of it, but there's available, consistent, I don't know what the I is for, and then durable. But basically, what ACID is the set of properties that like a good database should have. Durable is consistent. So it's a set of properties that like a database should have. So for example, if I run a query, I would like to have this concept of transactions. If I'm going to write 100 rows to some table somewhere, and then my server dies and the write fails 50 rows in, I would rather just have written none of those things. I'd rather be able to roll back the entire transaction and start from scratch, as opposed to having a half-written transaction, like this state that I don't understand.
Yeah.
ACID gets you those rollbacks. It gets you time travel. You can see the state of a database, the state of your data store at any point in time. If someone does a write, like consistency is if someone does a write, like if I'm a bank and someone deposits some money, someone withdraws some money from their bank account, like that withdrawal from their bank account should be reflected in the database so that if they go into another withdrawal, if the first withdrawal already set them to $0, they shouldn't be able to withdraw anymore. So what this is, if you have multiple people or multiple processes, like all querying the database at the same time, and some of them are doing writes, consistency is this property where there's no race condition. Like I got in first, I did this write, and now that write, like my current bank account balance at 0 is what you will see when you go to do your next. So if that was probably a terrible explanation, but no race conditions. If I do a write, everyone else's queries should have that write reflected in the data they see. And it would be really bad if you were a bank and didn't have that. So
yeah, it's atomicity, the first one.
Oh, is that what it? Oh, duh, you're right. I do that.
Yeah. And
atomic
then isolation.
Transactions.
Yeah, atomic, yeah. And then isolation for the I.
What is it? Isolation?
Yep.
Nice.
But yeah, we basically explained atomicity.
Yeah, I think
in your explanation.
So basically, like ACID, if something is ACID compliant, it basically means you can treat it as a database with transactions and stuff. So if you're going to try to separate storage and compute, and the way that you're going to do that is you're going to write a bunch of files to storage somewhere, and now you can write queries to it. You now really want ACID compliance on this approach to doing data, so that you don't lose things like people are able to withdraw more money than they technically should be able to from like an ATM.
Yeah.
And time travel is great. Anyway, so Parquet is just a file format. It's just a bunch of CSVs. Parquet by itself doesn't give you ACID compliance because this is more of a database concept. This is more about how you read and write from Parquet than it is the file itself. So enter Iceberg and Delta Lake. So the way Iceberg works is it says you store your data in these Parquet files. So you have lots of Parquet files just scattered wherever you want in an S3 bucket or something like that. And there will be a catalog thing up here, a catalog set of files or a service. And if I am a SQL query engine and I want to do a query against some of these files, give me the median sales or count how many names we have, how many distinct names we have in this data set. Probably what that query needs to do is it needs to know where all these Parquet files are. And then it needs to go read at least a portion of those Parquet files and then do some counts. So what the catalog's purpose is to essentially be a mapping of where I can go find the Parquet files that I need to do. So if you have a catalog and you have a bunch of Parquet files, then theoretically, you could use any program that understands the catalog to process this data and do that query. So you could send a Spark cluster at it. You could send Snowflake's like compute engine at it, or you could do Python, or you could do REST or whatever. There's a whole bunch of metadata that sits in between the catalog and the files. If you're going to do a query, it would be so blob storage does not like round trips. Like you want to be able to get your answer to your data questions in as few requests to blob storage as possible, because round trips cost you money and they're slow. One way you could do that, let's say I'm trying to calculate the median age. One way I could do that is I could literally loop over every single one of these files and query a portion of them, like every single one, which could be thousands of files or hundreds of thousands of files. So I could query 100,000 files in order to calculate the median age, but that would be really expensive and silly. So instead of doing that, what my program will do is it'll actually look at these, like this layer of metadata files here. And the metadata files have some summary statistics about what's in here. So if I'm literally just doing a count, imagine a metadata file with names of files here, and it just tells you the distinct count of the names in each of these things. If I'm trying to count names and the counts for like globally for these files are already in this metadata file, I don't even need to look anywhere further than here. I can just sum the values that are here in the metadata. So metadata is orders of magnitude smaller than your actual data. Like the Duck Lake guys said that it was 5 orders of magnitude smaller. So they said if it was, I'll probably get this wrong. I think they said if it's a petabyte of data, that's 10 gigs of metadata. It could have been an exabyte that they said. I don't remember, but they said some statement like that. So the metadata is like proportionally way smaller than the actual data that you have.
Yeah.
So yeah, what Iceberg and Delta Lake are doing is, I think this is how Delta Lake works. Definitely how Iceberg works is the metadata here is actually its own set of files. So you have a bunch of files for Parquet, but then you have more files that are like these summary files that you reach out to instead. Some of the files are actually files that they're like pointers in history. So let's say on Monday, I insert 100 rows, like 100 new people. And then on Tuesday, I insert 100 more people. I can time travel back in time to the state of the database on Monday and do a select statement. And the data that was newly inserted on Tuesday just won't even be factored into that select statement. So let's say this data file was inserted on Tuesday. I could time travel back in time to before this file existed, and I can just query these 2 files. That's one super cool thing about these file formats is they support time travel. So the metadata files, the metadata layer helps you with time travel, and it helps you with like this metadata summary of the actual data. And that plus some more stuff gets you full ACID compliance if you read and write from these files the way that you're supposed to, as prescribed by these formats. So what's just on a side here for ML, this is really great because it's possible that data version control has gotten better because honestly, I haven't looked closely at it for a couple of years.
I don't know what happened there. I didn't realize they were still around.
Yeah. I don't hear much about them anymore, but here's what I remember of data version control. So there's this thing in MLOps where reproducibility is extremely important. If I train a model that's going to be denying someone's insurance claims, and then someone basically goes to audit like the reason that I denied them their claim, they're going to come to me and they're going to ask me for all of the reasoning for why I denied them this insurance claim. And so I need to be able to reproduce that if denying their claim was a decision made by a machine learning model, then I need to go and I need to reproduce everything that went into that decision so that I can go defend myself in court and say that it's not because you're a woman, or no, it's not because you're black. It's actually because you're a risky person. So versioning everything about what goes into training a model is extremely important. So if you want to be able to retrain, like if it's 2025 and this is a model that we're talking about that's being audited from 2024, and now people are asking me to reproduce that model that I trained in 2024. I need to go find the exact libraries I used to train the model, the same libraries and the same like custom code that I wrote. But also, I obviously have to be able to find the exact data that I put into that model in 2024. Duh, if you don't train a model on the same training data, you'll probably get a different model. So it was a very hot topic and still is, this concept of versioning data. I should be able to version the data that goes into every model so I can go look it up later. But the way data version control at least worked, past tense, was it would literally make a copy of the entire data set that went into the model. So if I trained on a gig of data and I want to save, let's say I'm doing a hyperparameter sweep, and that's a bad example because they would probably be doing the same data. But if I make let's say I change my featureization logic, I decide that I'm going to represent latitude and longitude as like a single number instead of 2 numbers. I'll do a transform, I'll make latitude and longitude different, and then I'll train a model with that. When I save that data version, what data version control will do is it'll copy the entire training data set, but with the longitude columns changed. And then maybe I'll do a different change over here, and I'll keep copying these data sets over and over again. That's not great because that's a lot of storage, especially if you have like large-ish amounts of data, because every version of the model you train is a whole copy of your training data set. So what's cool about these file formats here and their support of time travel is maybe instead of copying the entire training data set, you could just store a timestamp of when your training data set was produced. And then if you want to go reproduce your original training run, maybe this is what it looked like. Maybe these are the 2 files you trained on. Just time travel back in time to when these were the only 2 files in your data lake. And then you have the original training set. So there's some hand waving there. Maybe there was a SQL query that was also used against these 2 files to produce that training set. So maybe you save the SQL query and the timestamp, but it's like saving metadata like that is obviously so much lighter than saving all this.
Yeah, too more efficient.
Yep. Sorry, I've been monologuing for a bit. Let's pause for discussion. Is any of this new?
No, I like it. It makes a lot of sense on the Duck Lake, and I feel like it perfectly leads into the demo.
Let's do it. Oh yeah, so what's the difference? So Iceberg looks like this. Iceberg is like this catalog. It's a bunch of metadata files, and it is a bunch of Parquet files. Delta Lake is also a bunch of Parquet files, and I think it's also a bunch of metadata files as well, and a catalog. So what's Duck Lake? What Duck Lake did is they basically grabbed a Postgres. What they basically said was writing a small amount of data, which they define as less than 100,000 rows. So if you're doing it right, it's less than 100,000 rows of data. They call that small. And they were claiming that like these file formats, because of blob storage, struggles even when you start to do writes that small. Because the way this works is every single time you do a write to your data lakehouse, you maybe write one or more new Parquet files, but then you also write one or more metadata files summarizing your new Parquet files. So anytime I do an insert or an upsert or a delete, I'm producing at least a Parquet file and at least a metadata file. So if I'm doing a lot of like small writes, then I'm potentially getting like a bajillion new sets of these files all over the place, and which is therefore increasing my round trips and stuff. And so they were saying even the metadata files can be a lot to scan through. And this is a potential bottleneck in performance. And so they were saying, what if instead of having like our metadata live in files, what if we actually had a database like Postgres, and we represented all this data as like rows in the Postgres database, absorb this all in here. And now to look up what files you want to operate on, you're really just like reaching out to Postgres real quick, and then Postgres can potentially give you those answers much faster. Anyway, so I think it's a cool idea. Technically, this announcement was like last week or the week before, so we'll see how it holds up, but I think it's exciting. So
it's definitely created a lot of interest by people, right? Like it's
yes,
curiosity. There's two separate things. Like DuckDB is its own foundation, and then MotherDuck is an actual company with VC backing.
Excellent. My entire knowledge of this comes from 2 chapters of a book about Iceberg, so I would not call myself an expert, but I have been a user of these 2 guys for a long time. So if I, as a hacker who wants to do things cheaply, can get a lot of the value without using one of these, then that makes me really excited. And you can use one of these formats with these 2 providers and feel less locked in because you can use different engines for different jobs. Okay, so yeah, so what are we doing today? So basically, I want to write some Iceberg files. I have the NYC taxi data set, which is a bunch of Parquet files about taxi rides in New York City. And I want to see if we can upload those files, these Parquet files, to S3. And then AWS has a catalog from the Glue service, so AWS Glue. We should be able to register these Parquet files into the Glue catalog in Iceberg format. So what that would mean is we land these in S3, and we make sure that the metadata files that like declares their existence also exists. And then we make sure that the AWS Glue catalog knows about that. And if we get all those things right, then we have a valid data lakehouse now. And so you could point something like Spark using Databricks or AWS Glue Spark or EMR at this catalog, and you could do transformations on this data. Or you could potentially use Python, which is what I want to figure out. What that would look like is we would have a Python process that would first, this Python process, it has to have IAM permissions to read this data, obviously. And it also has to have permissions to like talk to the catalog. So first, what it'll do is it'll go to the catalog and say, hey, I'm looking for this table called taxi rides. Where is it? What files are those in? Where's the metadata? And then the catalog will return a response, and then we'll go and we'll start doing some queries. Oh, and one really cool thing too here is like, this is something that I knew this, but I didn't put it together. So when you read a file with Boto3 client, S3, whatever, I don't remember the exact function call, but there's a way to read at a certain byte offset. So like you can read, so here's an offset, and then here's like how many bytes. Like when you download a file out of S3, you don't have to download the whole file. You can download like a specific byte range of that file. And that's one of the things that's cool about Parquet is like these columns are specific byte ranges within a Parquet file. And so like your data lake could be absolutely massive, but as long as your SQL query selects out a result set that isn't so big, thanks to S3 only having to read like certain byte ranges in certain files across, thanks to Python being able to do that with Boto, there's a good chance that many queries you write will work just fine. So even though Python runs on a single node, and traditionally you have like giant distributed compute engines querying across all this, if you write the right queries, it'll totally work. You can totally query stuff directly out of your data lake direct into Python, and that's cool. And I was talking to Vila Tulas, the CEO of Outer Bounds, which is the shirt I'm wearing, and he was saying that like a lot of data science workloads, like you can get really good performance for a lot of data science workloads. Like I think people say, oh, we have big data. That means we can't use pure Python. We have to use PySpark for our data science problems. And PySpark is powerful, but it's also very limited. Like the data science ecosystem is not in Spark. Like it's PyTorch, it's TensorFlow, it's Hugging Face. Like you can do UDFs in Spark, like user-defined functions. So if you train a model in Python, you can get that into Spark and then use that model in big data. But the training is definitely much harder. Like Spark has some great libraries. Like it has MLlib, which a lot of the things you can do in scikit-learn, you can absolutely do in MLlib. And I'm sure they can do neural nets and save those to ONNX. You could get it into Python. But I think the reality is data scientists are statisticians often and reformed analysts or like people from academia. You also get a lot of software engineering skilled data scientists, but like a huge chunk of the data scientist persona is not, they're not like strongly technical people. And so
yeah, that's true. They prefer to write like R than PySpark, you can imagine.
Yeah, exactly. So there's a lot you can get wrong with Spark. Like it's complicated. Like the tracebacks are notoriously difficult to debug. It can be slow because Spark has like a data frame concept, just like you can use pandas to do data frame operations. And so you can use Spark's data frame libraries to do a lot of transformations, but what's the UX between doing data frame stuff with pandas versus Spark? So what I'm trying to get at is I think Spark it's a necessary evil for many problems that involve big data.
True, yeah.
Because the ecosystem's not there and the DevX isn't as strong.
Yeah,
for example, with Spark, you got to pay for a massive cluster or a cluster of some size. You have to set that thing up or pay for databricks or someone else to set it up. You then, when you want to do data frame operations, you have to submit a Spark job. That takes some time. Like your Spark job has to essentially get packaged up and sent off to this cluster, and then that code.
With all your libraries, actually, with all your dependencies as well, which sometimes introduces like weird things.
Yeah, just the whole. There's some complexity there. And there's also some cost because like you're paying for some infrastructure too. And it's a little bit slower. There's this overhead of submitting your jobs. And then the debuggability is not as great. Can you step debug Spark? I don't know. I've actually never tried.
Yeah, I've never tried either. I just remember
you're going to be limited in exactly. Like the fact that a lot of your compute is happening via the JVM is going to limit how closely you could inspect it. So, so it's a very powerful tool. And it has a very mature ecosystem, but it's not ideal, I would say, for data scientists to use in terms of DevX.
Steep learning curve.
And what's crazy is that if you could do transformations in pure Python against your data lakehouse, you could make it cheaper because you're not paying for a Spark cluster. You could make it faster because you're not waiting for a Spark job to be submitted and facilitated across a cluster. You're literally just reaching directly out to blob storage and just downloading the files yourself. And it's also simpler because you can use the libraries and tools that you already know. And people say, our data is too big. Our data is too big to do processing in Spark. And to that, I would say, that's very interesting because Netflix and large scale companies or companies with lots of data do a lot in pure Python. They certainly have like big data lanes as well, but they can get a lot of mileage from these tools. And so in many cases, even if you have a giant data set, you'll often do some aggregations and transformations to curate a much smaller result set that ends up going into your model. So maybe what you do is you submit Spark jobs, SQL queries in big data land to featureize your data and get a much smaller training set. And then you pass that data. Well, and now that exists in a Parquet file. And now your Python process, which does model training, reaches directly after these files and grabs that smaller set and then goes off on its merry way. And I think it would surprise people just how much data you can process on a single node these days. So I think someone said that I saw, obviously there's lies, damned lies, and benchmarks, but I saw someone saying that like on a $20 Raspberry Pi microcomputer, they use DuckDB to process 30 million rows. So
nice.
I think that statement would have been wild, like back in the days of Hive and stuff.
Yeah. Hadoop.
Just what, and this is not to bag on Spark. Like the Spark ecosystem is actually really sick, but what does bother me is when people act as though Spark needs to be like the default for data science, where I would say it's actually a fallback in conditions where something simpler doesn't work. So
didn't work. Yeah, that's true.
Nice. So anyway, so that's the idea. So let's say you have big data and you're going to do data science. Start by doing some SQL queries or Spark jobs to aggregate that data into a smaller result set. get that into a single node, do all the exploration and experimentation you want on that node. And then now let's say you want to run inference on big data. This is an area where Spark really shines. You can take a model like scikit-learn or PyTorch or whatever, or even your own custom Python code, and you can serialize that and basically turn it into a user-defined function in Spark. And so now you can send your trained model that you built in Python back to Spark land, and now you can operate against big data if you need to. But even then, so even for companies with large amounts of data, I still think there's a ton of single node sized data batch inference use cases. Anyway, so this has all got me super excited because I always felt like, I feel like in my career, I've been running away from Databricks because there's this fear of high cost and vendor lock-in, and you got to do everything the Databricks way, and they want you to do everything with notebooks, and their Docker story is like really scary. So Databricks has always scared me, and yet I've been always like jealous of this idea of the data lakehouse, and now I'm like, oh my goodness, like we could use a data lakehouse. You use Databricks if you want, but I also can do Python however I think is best, using the real best practices and benefit from the structure and all the great work that the data engineering folks are doing to build this data lakehouse for us. Anyway, so that gets back into the demo. So like maybe let's see if we can get a data lakehouse created with just S3 and AWS Glue Catalog, which would be like zero infrastructure. And then let's see if we can query that catalog from DuckDB using Python.
Okay.
Back into single node land. One sad thing that I already know we're going to see is right now DuckDB does not have write support for Delta Lake or Iceberg. And part of me wonders, like, is this because of Duck Lake? Did they intentionally not add like write support for these file formats because they knew they were going to come out with their own? Like, probably not. Probably they're just resource constrained, and so they can't do everything. But man, there's a GitHub issue with 200 reactions on it where people are asking for Iceberg write support in DuckDB. And I think the current state of that thread is, I don't think that, so I think DuckDB is written in C++, and I don't think there's a good library in C++ yet for writing to Iceberg. If that's true, then that means there's not something they can straightforwardly import and implement into their tool. And it seems like they're not about to go write a C++ Iceberg writing engine from scratch. But it just makes me so sad because if they had it, you could literally do so much data engineering with DuckDB on single nodes.
Yeah.
Okay. And I'm sure MotherDuck has some cool offerings that help you get around that. But if you want to do DuckDB multiplayer or something. Okay. So let's try this.
Go for it.
I'm going to stop sharing my screen for a sec just to make sure that I don't have anything I shouldn't be showing.
Credentials.
Yeah. I don't think I have anything bad, but I'm not seeing a lot of activity on the chat. We're streaming to two places. We're streaming to both MLOps community and MLOps club. So I hope that MLOps community chats are coming through. If there's any MLOps community chats, we're not seeing them. So if you don't see it, maybe you can find the MLOps club version of the video. Let's see. So what do we got? I was hoping to live code some of this, and maybe we will, but to make sure we get to something interesting fast, I'm just going to use a Jupyter notebook that I was playing with before this.
Yeah.
All right, let's do this.
Experimentation phase is always in Jupyter. We have a chat, I think, from MLOps community. Mikal said, Duck Lake, please.
Nice.
So here we are.
All right. Let me do a little login here. AWS SSO file. Let's do DuckDB profile. Oh no. All right, one sec. Let me get logged into AWS real quick. All right. I'll make this bigger. Okay, validating credentials real quick. AWS S3 LS profile. DuckDB. Oh, cool. Did not return a failure, so we're good. I made a clean AWS account right before this, so we have a fresh blank canvas to look at here. Okay, so let's go to the console. And let's go to AWS Glue and also S3. A catalog is just a directory of tables, essentially, and data that's in those tables. It could potentially be part of the governance story too, although I don't think you use Glue for data governance in AWS. I think you use Lake Formation for that, which is a separate service. But anyway, so if you come into, so I'm going to go to US East 1 here.
Default.
So I'm in AWS Glue, and I'm looking at the US East 1 data catalog, and I clicked on databases. There's no databases in here, so we're going to create a database. And then go to North Virginia and S3 as well. There are no buckets. And so fresh on databases and fresh on buckets. So let's go create both of those things. We could create it in the UI. I just really don't want to. I'm going to use UV to install a couple packages. And one of those is Pulumi, which is an infrastructure as code tool. We're like with 2 lines of code or so, we can create this bucket in this catalog. UV sync. All right, cool. How's my VS Code Jupyter doing?
Try to enter it.
Right.
Did you install IPython in the VM?
I believe, yeah. This UV log file I was using earlier for the same notebook, so it should have everything we need to run.
Okay. Nice.
Oh man, how do I select a kernel? These are all my global Pythons. I don't want those. Okay, select interpreter. Can I just...
Usually when you select the interpreter, it's
good.
better. Yeah, there you go.
Okay, nice. Okay, let's run this. Please work. Okay, that seems to work. Set a couple of environment variables. We're going to work in US East 1. I'm going to use my DuckDB profile. Pulumi can encrypt secrets and stuff locally. And anyway, so I want Pulumi. If I was going to do anything sensitive, I'd want to encrypt secrets or whatever that I'm creating with Pulumi. But for local development, I just set that passphrase to nothing, and encryption's anyway, not super important, but it has to do with Pulumi. So we're going to create a bucket. Let's do MLOps club data lake stream. And so we'll create a bucket with this name. We'll create a Glue database called NYC Taxi, and we'll create a table in that database called Green Taxi Trips. And we have a bunch of Parquet files that are the Green Taxi Trip NYC dataset files. Let's run that, and it works. So now Pulumi is really cool if you haven't looked at it before. There's Terraform, there's CloudFormation, there's AWS CDK, there's Pulumi. They all have strengths and weaknesses, actually. And it's difficult, I think, to self-host Pulumi. So if I were choosing my own infrastructure as code tool in a shop that exclusively used AWS, I definitely would choose AWS CDK. But if I didn't do that, I would choose one of Terraform or Pulumi. Pulumi is a little harder to self-host. And so if you want to just follow the beaten path, then I would go with Terraform/OpenTofu. But I love to experiment with Pulumi whenever I can. So that's what I'm doing here. And what's nice about this is Pulumi has this sweet Python SDK where we can create infrastructure as code from Python and still get like the cool state management and stuff. Anyway, Pulumi has this concept of a Pulumi program. And so this function here, this is like my whole IAC stack. And you can see I'm creating a bucket, which is of type AWS S3 bucket. And I'm creating, I'm creating a Glue database as well. So AWS Glue Catalog database. All right. Interestingly, I'm not creating a table. I thought that you used IAC to create tables, but actually maybe that's not true. Maybe you create only databases with the AWS APIs, and then tables come through the engine. Anyway, so I have this Pulumi program, super simple and not very much code. And then the rest here is some boilerplate to execute that program, basically. I named my stack. I named this thing called a project, which is a Pulumi concept. And here's the line of code where we actually create the infrastructure. And everything else here are just some nice print statements. So running that. Warning, a new version of Pulumi is available.
So Glue will host our actual Parquet files, or like the thing that will act as the manifest and the catalog, or both of them?
The directory. So the files will be in S3, and then Glue will be this directory that says, I have this table name, where are the files that belong to that table name?
Got it. It's basically AWS's Iceberg.
Yeah. Like you can use Iceberg format on AWS, and Glue plays the role of the catalog for the Iceberg format.
Okay, gotcha. It knows how to speak Iceberg correctly, you can say.
Yeah, exactly. Okay, we now have a database. Sick. NYC Taxi. What up? Okay. And then we have a bucket, hopefully. Buckets. Where are they?
General purpose buckets. Yep.
Yes. Okay, nice. We have a bucket. By the way, there's this thing called table buckets, which is like a special kind of bucket just for Iceberg. And it can do some nice Iceberg things for you that I won't talk about right now. But a lot of people steered me away from using table buckets because they were like, it's more expensive. It's for the same thing. Like everything that table buckets do, you can do with general purpose buckets without a ton of management. Anyway, so I don't actually know the cost difference between table buckets and general purpose buckets, but apparently there is one, and they're a bit more expensive. So if you want to totally roll your own Iceberg on S3, you can do that for cheaper. Okay, now that we have a database, so let's go look at the database. So clicking on this, when you click on a database, you see a list of tables. We have no tables. There are no tables in our database. And so if we were in Snowflake right now, or if we were in Databricks, we would do some sort of SQL query like this. We'd like create or replace table, and we would create a table for ourselves. Like whenever you give a command like this to a query engine, such as Spark SQL or to Snow SQL, you end up, the query engine takes that as a command, and then it goes and does something to the metadata. So instead of running this directly, we could use a Python library to do the equivalent change to our metadata in the underlying S3 files and the Glue Catalog. And functionally, it would be the same thing. So we basically need to perform the equivalent of this in Python.
Yeah.
So here's an interesting line of code or block of code. So there's a library called PyIceberg, which is a library in Python for reading and writing Iceberg format. And they have the concept of a catalog. And I think this is just a great abstraction. Excuse me. So there's this function called load catalog, which can establish a connection to a catalog, and it returns an instance of catalog. Using the catalog instance, you can then access your tables, and you can read from them and write from them, and you can do time travel and all that stuff. So once you have this catalog object, you're in Iceberg land. And what's great is you can pass properties to the catalog object to do your auth for you. So these are properties that I would pass to the PyIceberg library to use AWS SigV4, which is like IAM's authentication, what would you call that, protocol, to basically establish like authenticated, authorized connectivity with our Glue catalog. It is essentially, let's see, is this credential vending? I don't know if this is credential vending. Like, I think in the Databricks world, there's some excitement about credential vending because I think that it's been difficult to access data via the Unity catalog outside of the Databricks ecosystem. But thanks to credentials vending, I believe Databricks can actually vend you some credentials that allow you to pass Databricks credentials to other programs and now access it.
Yeah.
So this isn't credentials vending per se, because it's not like we're asking AWS Glue Catalog for permission. Really, we're just using IAM with my AWS profile, which has administrator access, and using those credentials to do operations against Glue. So anyway, if you've been following the credential vending stuff, this is where that fits. All right, run this guy. Please work, please work, please work. It did. It didn't crash, so great. Okay, so I haven't shown you the Parquet files yet, and even if I did, it would just be a bunch of bytes. But like, I could, do I have some pandas code? Oh, I do. Good. Here it is. Here's me listing one of the Parquet files with these information about these taxi trips. I guess I'm doing df.describe here. So these are like some summary statistics. But yeah, there's some columns. There's a vendor ID, there's a pickup date time and a drop off date time, and some other features here. This is what the data looks like. So if we wanted to create a table in our Iceberg data lakehouse, in SQL land, we would do something like this. It would be a create table statement, and we create in our catalog, in our NYC taxi database, we would create a table called green taxi trips. And then we would have to do some DDL, like some column names and some types to basically register that table in Iceberg. Thereafter, if we tried to insert data in like in an Iceberg compliant way, our client, it'll look up these types, and then it'll look at our Parquet data and do some validation before it goes and just writes those out to S3. So declaring this here makes it so that we can have schema on write. So anytime we do inserts, we check against this DDL and do our Iceberg operations. So this query is using Athena, which is cool. Athena is a distributed SQL query engine on AWS that's serverless. And so whenever you run an Athena query, presumably some Athena workers are getting spun up behind the scenes, or maybe some existing workers that already exist are there and now you're using them. This query gets submitted to those Athena workers, just similar to like how Spark SQL would. And those Athena workers go and do the operations against those files in S3s to make it happen. So this Athena is a SQL query engine that can operate against Parquet files, just like you can with Spark SQL and PyIceberg and DuckDB. So it's so cool that our data is going to be in Iceberg and fully unlocked, because nothing would stop us from using Athena to do largish data transformations on Iceberg. So earlier I said, if you have big data and you want to do ML, maybe do your aggregations using Athena and then do the last mile stuff in DuckDB polars or something.
Yeah.
So cool. Notice that with Athena, you specify the location that you want, like the bucket and the path that you want these physical Parquet files to end up in. That's because like at some point you have to tell AWS, at some point you have to tell Python, the Python client, where to actually write these files to. And so you specify that bucket here. I would never want data scientists to actually have to know where the bucket is that they're physically querying against. That would just be so annoying if they had to know where the Parquet files were they were querying against, and they don't have to. So once this entry is created in Glue Catalog, we'll have a table called green taxi trips in this database, and it'll be like an implementation, like metadata detail that this table happens to be associated with this particular path. Whenever you use PyIceberg to then go do inserts into this table, PyIceberg behind the scenes will interrogate the Glue catalog, find out where this is, and it'll go write those to the correct location for you. So functionally, you won't ever have to think about you won't ever have to think about the locations of the raw files yourself, which is cool. And I believe, and the same is true in Athena land. Like once this is in Athena and you're just doing select statements, you'll select out of this table. You don't have to think about the physical location. Unless you're doing further, like you could do create table, blah, blah, blah as select, and then do a big select statement. And then you would have to specify the location of that one. So anyway, so I guess for some use cases, thinking about underlying S3 paths is going to enter your life if you start using this, which is a little sad to me, but I think that at least is workable. But I would still, as a platform person for data scientists, I would still probably want to like abstract this away from them and maybe derive a path from their table name or something. All right, enough talk about engines. Yeah, we ran this, or let's run it again and just see. Oh, check it out. I'll skip to this line. So here's our Iceberg catalog instance that we got earlier. On that catalog, we can do a create table if not exists function call. And this is presumably reaching out to the Glue catalog right now and basically registering a table at this database name and this table name. Skip discussion about partitions right now, and then it's declaring this location. So this Python snippet is the functional equivalent in PyIceberg of this create table statement.
Yeah.
Oh no, why is this not working? Oh, I flipped. Do I not have the data?
Oh,
I thought that I had that. I have a Python script I think I can run to download the last 3 months of the green data. Let's see if we can vibe code that easily. So wait, what is this? Copy path, UV run. It'd be way cool if this worked. Oh, this might be, I might need a different UV environment for this. Or not.
Looks like it's going.
Oh, good. Okay. We're getting some data. Amazing.
Nice.
Hopefully my Jupyter notebook knows where to grab that from. I'm just using pandas here. Okay, good. Nice. It worked. Data's back.
Nice.
Okay, I want to talk about PyArrow because it's just so cool, but not yet. Not until we're a little further into this demo. So let's try our create table if not exists block again. Okay, created Iceberg table, green taxi trips. And here's a nice convenient link to take us to it. And awesome.
Nice.
Fetching green taxi trips.
So Athena is essentially like the compute layer when we separated out the compute and storage in databases, because like it does like queries on. Oh, nice.
Yeah,
that's cool.
Yeah, the three components are like you got a catalog. So you got data files, which are Parquet, and then you have more files, which is like the metadata layer, and then you have a catalog, which there's like a REST spec. If you can be an Iceberg compliant catalog, if you build a REST API that implements the Iceberg catalog contract. Let's see. So yeah, you got your catalog, you got your metadata files, you got your Parquet files, then you also have like your engine, and the engine like works with the former three to do what it needs to do. Wow, I'm surprised this is taking so long. Let's see. All right, cool. Green taxi trips. We have a table. It's called green taxi trips, and it's in the NYC database. And look at its location. It's the location that I specified. So we just registered a table with locations. Now we can do operations on it. So I'm going to click on the table, and I will show you. Look, the table has a schema. These are the columns, and these are the data types. I don't know if these are exact data types defined in like, I don't know if the Iceberg catalog format takes a stance on D types or if it defers to Parquet for those. So I'm not sure if these are like some Glue concept of types, a Iceberg concept of types, or a Parquet concept of types, but it's probably going to come from one of those three things.
Yeah.
And let's say it's a Glue catalog type, then that probably ends up getting translated to Parquet types at some point.
Whichever.
But how do these types get here? because all I did was say create a table and I gave it a name and a location. The way the types got here is this line here, the schema property. And it looks like I didn't have to use much code to get these types. Like I have this one line of code here, and then I get this thing called an arrow df, and that apparently has a schema on it, and it has our types. What I've done here is this is actually really sick. I want to go back to our diagram here. So earlier we were talking about Parquet files and how Parquet files are this representation of data on disk, but there is it's Apache Arrow. There's another project, which I don't know when it first came out, but it's been a huge buzzword with a lot of hype around it in the last year or two. And it's called Apache Arrow. And
I've heard of them actually.
So it is really the same. It's a very similar thing to Parquet. It's a way of representing columnar data, but not as a file format. It's a way of representing it in RAM, like in memory. So you could have you could have a Parquet file or a CSV file or whatever. And let's say you want to read that into pandas. Like, how does pandas see that data frame in memory? Now pandas actually sees it as like this Apache Arrow format. So when you load in, these columns are going to be loaded up next to each other in your RAM, in your program. And I think, what's Apache Arrow written in? Is it C+ or Rust?
Oh, I think it was released actually 8 years ago, so probably C++.
Probably C++. Yep, written in C++. Okay, great. So there's a canonical Apache Arrow implementation written in C++, and it has bindings in Python and a whole bunch of other languages. So like Python has this sweet data frame library, which is pandas, which like a lot of us learned data frames first with pandas, and R has data frame libraries as well. And now there's new data frame libraries in Python like polars. But what about all the languages that never really were known for data manipulation? Like how many analyses have really been done in JavaScript or Java? There were probably some data frame libraries here and there, but I doubt that they were anywhere near the level of performance and organization as pandas has been.
Yeah.
And R and Python had these mature data frame libraries, but what about the rest of the world? So thanks to Apache Arrow, it's the standard for storing data frames as memories in memory, including like its own concept of like data types and stuff. It might have opinions on how operations are done, although I'm not sure. That might be something that's left to the individual data frame libraries themselves. But suffice it to say, at least for how these data frames are represented, any language that can use C+ bindings can now use Apache Arrow. And so now like data frames are democratized across all programming languages and even across different libraries.
Yeah.
So now pandas actually uses Apache Arrow under the hood, and so does polars. So the data frame libraries in Python, they've become wrappers around this. And so Apache Arrow, very similar to Parquet, is columnar storage. It's got columns, and it also has D types for those columns, like int or whatever, int 32, int 64. So I had loaded in a Parquet file as a pandas data frame previously here, and then we had described it here. And now I'm actually getting a PyArrow. So I'm essentially getting a reference to the Arrow data frame that's already inside of this pandas data frame.
Yeah.
So now this is an Arrow data frame, and Arrow has a schema thing on it, which is its D types. Nice. So yeah, you can give that Arrow schema to Iceberg, and now it's done schema inference, which is really nice. I don't know how much inference there really was to do because all the D types were already in the Parquet file, but we were able to grab those D types out of Parquet thanks to PyArrow and pass that schema to PyIceberg, which was then able to register all those D types in the Glue catalog. So yeah, there's a ton of metadata passing going on right here.
Yeah.
Isn't that cool though? There's so many cool developments happening in open source like data.
It is, yeah. I didn't know that we could get like a schema with one line. That was impressive.
All right, let's insert some data into the table now. Basically, to insert some data, we need to write the files to S3, and we need to make sure that the metadata files for that write operation also end up in the S3 bucket. Here, I'm doing a glob search for all my Parquet files in the data folder, and then I'll loop through each of them. And then for each one, I guess I'll read it as a pandas data frame. I'll get the PyArrow representation out of that data frame. And then on our catalog, I'll load up the table object for our database and table name. And then on that table object, I'll append this data. And I'm only going to do that for the first one because actually it'll break if I don't, which is a sad problem that I've run into. I'll show you in a bit, but
sure.
Okay, cool. Data inserted, bro. Let's
Nice.
do this. Let's go to our table.
Yep.
All right, go here. It would be great if we could preview this. We'll do that in Athena. But can we get a convenient link
Column
to
statistics, maybe?
overview of the data profile, distinct values? Huh.
Hmm.
Oh, we'd have to like generate it. Let's head over to Athena. All right, launch query editor, catalog, none. Okay, database, NYC taxi. Look,
Nice.
Athena knows about our taxi trips data. Awesome. In order to preview our data, I might have to set up a work group. So let me check that real quick. But can we just do a select star from green taxi trips, limit 10? And let's see, it's not going to let me run that because
I think it needs a results location.
yeah, before you run your first query, you need to set up a query result location. Yep. Let's just use the same bucket that we have.
Sure.
I have a folder for Iceberg. Let's not use that. Let's do a different folder. Athena ad hoc queries.
Yep.
Great. Can we copy the URI? Thank you. Good. Awesome. Assign bucket owner full control of query results. That sounds like something I want. Save. Editor. Here. Okay, run. Dude, look at that sweet
Nice.
data. That's so cool.
Query. Yep.
This was magical for me just because of the way AWS Glue works normally. Like Athena has been able to query Parquet files for a long time, but in order to do that, you needed to scan them. So you would run an AWS Glue crawler job, which would crawl your files and infer the schema and make sure it knew where they all were. And then you could, and then the catalog would know about them, and then you could do Athena queries. Like we didn't have to run a Glue crawler to do this. We were able to just insert, because what does the Glue crawler do? It does metadata stuff. It reads bits of the data and registers the metadata. We already registered the metadata in PyIceberg, so we didn't need to run a crawler. So that's just awesome. And there's a pretty good library, AWS Data Wrangler, that lets you do many data operations in AWS. And one of them is easily running SQL queries from Python.
Nice.
I'm going to comment out this one. So here's a query. Select star from AWS Data Catalog, doing a filter on the pickup times. And so where pickup times are more recent than 2024, 1201, limit 1,000. So we'll run this query using their client function. So please work.
Nice.
Dude, we just did the query from Python. We can already do queries from Athena stuff in Python, but it's just so cool that we can.
Yeah.
And we used Athena to do that. And yeah, we could already do Athena queries in Python, but what about other ways besides Athena to query this data in Python? Like the data's all in S3, so anything that can access S3 should be able to do this.
Yeah.
But before, yeah, okay. This is where I got stuck with DuckDB. So if you go to the DuckDB docs, DuckDB Glue Catalog. By the way, Amazon SageMaker Lakehouse. Amazon SageMaker used to be the thing where you did AI and machine learning stuff. They've renamed the old Amazon SageMaker, where you did AI and machine learning stuff, to Amazon SageMaker AI. So if SageMaker models, model registry, SageMaker pipelines, all that stuff is in Amazon SageMaker AI now. And Amazon SageMaker AI lives in the greater Amazon SageMaker umbrella, which now includes all the AI stuff and all the Glue stuff and Redshift and more. So I think AWS essentially took all their data services and moved them into the SageMaker umbrella.
Yeah.
So we want to connect to the Glue catalog, but now it's the SageMaker Lakehouse catalog. Anyway, so let's try to do this with DuckDB. So they show you how to connect to the SageMaker Lakehouse using DuckDB. But the example that they show has this S3 tables catalog thing inside of the connection string. But we're not using S3 tables. We're just using Glue Catalog. And for the life of me, I could not get this to work before. So let's try again. Yeah. So let's see if we can get that now. I think so. Let's see. Can we do? So which DuckDB? DuckDB not found. Okay, cool. So UV add DuckDB. Let's do it again. Can we like force reinstall? Refresh. Force reinstall. Good. Okay. UV list grep duck. Oh, is that another thing? UV pip list. Okay, we have DuckDB 1.3.0. Okay, cool. So UV run DuckDB UI. What? Failed to spawn DuckDB. We just installed it. What? DuckDB is a Python library. Do we need to
Is
install?
there CLI, maybe called DuckDB CLI or client or something?
I would have thought that would come with it. So
Yeah, usually it does.
let me check my project toml. So there's that. This is where it'd be great if someone in the chat who knew more about DuckDB than me could tell us what to do. All right, we'll do this the old-fashioned way with pip. So yeah, uv pip install DuckDB. Where's our, let's see, uv run, where's Python? Here's our virtual environment here. Is there a DuckDB executable in this thing?
I don't think so, because they say the DuckDB CLI is a single dependency-free executable, precompiled for Windows, Mac, and Linux. Yeah, with like stable builds and whatnot. I'll send you in the private chat that we have.
So I wanted to make sure we had the latest version of it. That was my main thing. So install.
I think 1.3 is the.
You can probably get it with brew. Okay, environment Python. Let's see.
But yeah, command line is different. Like it's its own thing, I think.
DuckDB CLI install.
No, it's there next to Python.
Oh, was it?
Yeah, on the left. There you go.
But this is the CLI and this is the library. I feel like these are all just. To me, these are all just different ways of installing the same thing. But okay, cool.
The way it reads, like the CLI is its own thing.
This is not how I'd prefer to install something, but maybe it will work. All right. What I was trying to do here is they have this cool Jupyter Notebook-like interface for DuckDB. Mm-hmm. I was hoping we could use that, but
like a GUI essentially.
Exactly, but we can execute DuckDB stuff from the notebook too. So here I'm importing DuckDB, I'm importing Boto 3. I'm using Boto 3 to get my account ID, and then because we're going to need that in one of these DuckDB queries. And now here's a big query that will pass into DuckDB. And let's see. So we'll run a command to install the Iceberg plugin for DuckDB, and then load that plugin, and then we'll create a secret. So why did I do this? This is where I think we need to refer to those DuckDB docs. See if we can get this right. So they're having us create a secret that basically just uses the AWS CLI credential chain. So it should just be able to use my profile. So let's see about this. How different are these two things? Type S3, provider credential chain, STS. I'm doing region and profile, and they're doing assume role and region. So that is different for sure.
Yeah, I imagine like they use roles because it's like services talking to each other. So
yeah, let's just run it and see. Anyway, after we have this, then we will attach to the catalog. Let's see. So attach account ID, S3 tables catalog, namespace name as Glue Catalog, type Iceberg, endpoint type Glue. We're doing type Iceberg, endpoint type Glue. I'll take this out. This was like me grasping, trying to get this to work the other day. So endpoint type Glue, so we'll just take this out. And the secret. They're not specifying their secret, so
that's true. And Glue is all lowercase, not even in quotes. So I don't know if that will make a difference. But
oh yeah,
it's not a string. Yeah.
Sweet. All right, let's see if we can run this and show all tables. See where that gets us.
Wait, we forgot the closing bracket.
Let's see. Do you see any? Oh, comma.
Oh yeah. Okay. Maybe, yeah.
All right. HTTP error, failed to query this URL. 403 thrown. The security token included in the request is invalid. And if you look at this URL, I remember thinking it didn't look right. So glue, US East 1, that's all fine. Erg, v1 config, warehouse equals, I think that's the account ID, and then NYC taxi. That actually looks better, I think, than it did last time I did this, because last time
403 is forbidden, right?
Yeah, and which makes sense because it's a security token issue.
Did your profile login expire on the command line, or
no? Because we were just able to do these Athena operations. So work.
Yeah.
So yeah, I haven't been able to get it to work. At least not using the profile, but we could go create a role for this and see if we can get that to work.
Yeah, I roll in an R, get its ARN. Maybe, yeah.
Yeah, so I'm super bummed about this because I really want DuckDB to work because DuckDB knows how to DuckDB is SQL, and SQL is a great way to query a result set out of a data lakehouse. That's how I would, SQL is the interface I would want to use to do that. But I want to be able to do it from a single node. And I cannot get this to work. I fiddled with, in their docs, they have this general like Iceberg REST catalogs thing where you can theoretically attach to any anything that implements REST. So I tried going straight through this and putting in all the glue information to authenticate that way. And I actually got a little headway there, but it still didn't work. So the two things I haven't yet tried are I haven't tried just doing this golden path of just using S3 tables. And I also haven't tried, it's so bizarre to me that S3 tables catalog shows up in that connection string.
Yeah, hard coded.
Oh, actually, and I'm actually not doing that here. So maybe we should try that. It's bizarre to me that where they say this is for general SageMaker Lakehouse and Glue, that S3 tables catalog shows up here.
Yeah.
Here's the other thing. It makes me think that S3 tables probably show up in Glue, which is fine. But what if you're not using S3 tables? What if you're just using vanilla S3?
Yeah. The level of abstraction isn't clear here. Is it like something Glue uses or should we use?
Let's see. I'm going to put in some stuff here. Namespace name. I don't know. Let's do the NYC taxi. Take this out. Put it here. So yeah, let's try this S3 tables route. Yeah, S3 tables catalog, NYC taxi. Like I see that, I'm like, that's weird. Anyway, so I played with a bunch of different variations of this. Went on GitHub issues. Other people have had on and off struggles with authenticating with Iceberg as well. And people had issues with using an SSO login, which is what I did to log into AWS. So I don't know, like maybe I need to create a role. Maybe you have to use hard-coded credentials from environment variables. I don't know. So that's just, suffice it to say, it's a huge bummer so far. And then the other thing obviously is like, you can definitely use this to do reads of data out of your Iceberg files, but you can't do writes back. So any sort of create table as sort of stuff in DuckDB, like that's a no-go because DuckDB doesn't support write support. Right, it doesn't have write support yet. And the same, I believe, is true of the Delta Lake format. So then I started asking myself, okay, if I'm going to use Iceberg on AWS Glue and DuckDB doesn't have support, what are my other options? So there are some other options. So one is you can always use Athena. You can always use Athena to do a query like this. Instead of doing create table and then a bunch of DDL, you would do create table, blah, 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 as select, and then do it whatever select statement you want. Still select your partitions, still store it as Iceberg, still specify location. So you can write Iceberg, read and write Iceberg to your heart's content from Athena. Another thing you can do is you can still use PyIceberg like we just did. But notice that when I used PyIceberg, the operation I did was an append operation. So let's go look at that.
Also, you said it failed or will fail if it's more than one. Doesn't update the manifests in turn? Maybe?
Yeah, let's try that here in a sec. But yeah, so I'm doing this append operation. That's a dumb operation. Like it literally just grabs this data set and just yeets it into S3 basically. There's other kinds of write operations besides append. What if I want to do an upsert and edit some rows that already exist? Like that's totally a thing that you would do in a data lakehouse sometimes. And we gotta shout out our boy Matt Martin. Let's see, LinkedIn, Matt's awesome. He's a data engineer. He has a Substack, and Substack's SEO is really good, and the content that Matt writes is also really good. So when I've been Googling things for Iceberg and DuckDB and Polars and all that stuff, I found a lot of content written by Matt here, and I was trying to get this POC together, and I wanted to show how an upsert worked. And guess what? The guy who did the PR into PyIceberg to add upsert support was Matt. And
wow.
Like my mind was blown because usually PRs aren't made by people I know in real life. I don't know Matt in real life, but I know of him on LinkedIn. So anyway, I was like huge fan of Matt. I just think that's awesome that he added the upsert support. All right, Matt, let's see how good or bad your upsert support is. Upserts, aka a merge operation, if I have this right, they allow you to modify, like basically create if not exists a row or modify it if it does exist.
Yeah.
On what basis do you determine if a row already exists or not? You do that by checking matches for columns. So basically, if I had a data frame that was like name, age, and then I had Eric and Hassam, and then so here's my data set right now. Let's say this is what exists. And now let's say I go to an upsert operation with this new data frame, and I take Eric out and I put Amit in here. Hassam is the same between the two, but Amit is new. And so
Yeah.
what the upsert operation will do is it'll have you pick the columns that you want to match. And so if there's already a column, let's say we're matching only on names, like we put in the name column. If the incoming data set here has a name that matches anything in the existing data set here, then basically join those things and update those values. So if there
it
were
will change.
exactly. So there's a Hassam here. And so if we're matching on name, it'll find the Hassam here and upsert that name. There's no omit here, so it's just going to insert omit.
Yep.
You can do that with multiple columns. And so if you want to do like a true upsert, if you want to do an upsert and be as confident as possible that you're updating the right rows, you should check. You should basically match on any rows that are not the ones you're trying to update actively. So like,
okay, because is it greedy? If there are multiple Hassams, it'll update them all.
I assume so. It's been so long since I did an upsert operation in any database that I just don't remember. But I think there may be a risk, if I understand this right, of like maybe adding too many rows or something. Like, so, because what if there were like multiple omit rows here? Like, what happens? I assume that this is, if there were already an omit here, I assume that like you end up attempting to do 5 different update operations on this, not on the same row, but writing new rows.
Yeah.
Anyway, but so the more properties you can join on, I think the less risk there is of having multiple matches.
Gotcha.
And sometimes you probably want multiple matches. Go and update all the rows for Monday to be Eric. But for a person, obviously, you're looking for a specific individual. So
yeah. The more columns you use, the better.
Exactly. So the upsert operation, the way that Matt wrote this operation is you load up a table. I mean, so it's compatible with the catalog. So you grab an Iceberg catalog table and you can now call this .upsert operation on it. You give it the data frame, a PyArrow data frame that you want to insert, that you're doing your upsert. And then you say what your join columns are. And you pick uniqueness and stuff. And you can say whether or not it's case sensitive. So pretty nice interface. I think this is like actually really simple and elegant. Yeah. Okay, let's try. I'm going to do this one. I'm going to, I don't want to have duplicate data. Yeah, so I want my pipelines to be idempotent or idempotent. Like last time I ran this on only one data frame and I appended it. If I were to run this again, it would append the data frame again. And we would just have like duplicates on duplicates of rows. And that's not a good thing. And it's better to write pipelines that are idempotent, where it doesn't matter how many times you run the pipeline. If you've already run it once, the next time you run it, it'll be like, oh, this data already exists. I don't need to change anything. And that way you don't have this duplicate data problem. So it's better. It's just generally better to use upserts when writing. And this is definitely what I'd much rather see. So let's get rid of this. Okay, so let's attempt to do an upsert, and what'll happen? This one might work. Invalid literal none. Okay, so I tried to get this to work. I don't think it's an issue with the upsert function. I think it's an issue potentially with my NYC taxi data.
Oh, okay.
I don't fully understand the problem, but with some like cursory poking around at it, I think that maybe some of my values in this data frame are null, and maybe because of that, it can't join on them. I'm not sure. So
maybe I don't know how none is treated like by PyArrow as a data type, and how the matching, when it comes to matching it to the schema, treats it. Does it treat it like none as a string or as a null pointer and stuff like that? So maybe that's
I'm not sure. There's definitely a concept of null, of nan, but
yeah.
Anyway,
you
so
could try to fill NA, and it will fill all the nuns with I think fill NA.
Yeah. I did some stuff here, like along this. I tried dropping. I wasn't able to get anything. But yeah, let's try filling all the NAs with null and with 0 and see what happens. Expected bytes got an int. Conversions failed.
So column has
there's
type
some like
object. That's a bit weird because the type object in pandas is like the old representation for string, I think.
Oh, is it?
Yeah.
I always thought objects is just like whenever pandas doesn't know the D type, or whenever you have mixed single column, like so I was never able to get this to successfully run on the NYC taxi dataset, which was a huge bummer. So I would love the NYC taxi dataset is a pretty like canonical, like a hello world dataset for big data things. So it'd be cool if someone else has a PyIceberg NYC taxi dataset that uses Upsert, because at some point I want to see what this looks like when it works. So yeah, I had some issues with Upsert, and I had some issues with DuckDB. And at that point I was getting pretty discouraged because I was like, dang, I really wanted a data lakehouse that I could use from Python. And it's probably user error. I'm sure it is, but I'm an experienced engineer. I can read docs and try stuff, and I wasn't able to get it working. So that probably means there's enough friction that others are going to struggle too.
Yeah.
So yeah, the general vibe I got when I was looking through this is the ecosystem feels pretty young. Like Spark has terrific support for reading and writing. So if you do data frame operations and you use Spark, you can expect that all the data frame stuff is going to work on Iceberg, or at least on Delta Lake on that file format.
Yeah.
But when it comes to anything else, I guess anything that relies on C++, because if that's DuckDB's reason for not having write access, then I guess all other C++ things would have that same limitation. So there's probably the number of things that can actually do writes seems potentially really limited. And I'm struggling to get reads working, at least from DuckDB right now. And so the fact that there aren't more people complaining about this, it just makes me wonder, is anyone really doing this? Is anyone really doing this successfully at work? I don't
know.
Yeah. So it's super promising, and I hope that people are, but just I look at the libraries and I'm like, wow, they're really undeveloped still. And I thought that I was late to the game on Iceberg, but it seems like the broader ecosystem is still making integrations happen.
Yeah, I think it's very enterprise heavy. And outside of that, I think these are just the tools that we have and they just came out. So it's pretty young outside of the like enterprise land. And that's why maybe not.
I was thinking too, like, what are people's motivations? What is DuckDB's motivation to add support? DuckDB as a tool, of course, the tool would say, the foundation would probably say, oh yeah, that's a great idea because Iceberg is this format that people are really excited about. And I dare say, at least for me, DuckDB wasn't even on my radar until all this Iceberg stuff. The only reason I was interested in DuckDB was because it gave me a way in Python to use SQL to query against a data lakehouse. And then when I went to do it, I couldn't. So I don't know. There's at least a sample of there's a sample of at least one person and probably more where the only reason like they cared to look at DuckDB in the first place was because of support, because it opened up an avenue to access a data lakehouse.
Yeah.
Mother Duck, if Duck Lake's going to be the thing, their new file format, like how invested are they? Like how incentivized are they to actually implement Delta Lake support and Iceberg support? They may not be against it, but in a sense, it might compete with business interests now. And maybe the same is true of getting out of Spark. Spark may have read and write support, but when you use Spark, now you go and you maybe buy EMR, you buy Databricks or something.
Yeah.
So it makes sense why like the JVM world would have good support for all this stuff, but not like the C++ Rust Python world. And with AWS, like maybe they could go add write support for Iceberg, but like right now, like Athena works great. So like Athena and Redshift will pay them. So yeah,
that's true.
So I don't like. Hopefully I'm just trying to think. Yeah.
No, I was just gonna say we will. I don't know. We'll try to tinker with it. Maybe next office hours we'll have something about this. So stay tuned.
Yeah, I think I'm gonna wait and watch. What was I gonna
say? Okay.
Finishing that last thread, I can't think of a business group who's super incentivized to make write support for these file formats happen, and maybe other stuff too. I don't know in which business's interest is it for the Python read and write support, for example, to be really good. I don't know.
Okay.
Yeah. So can we kill Databricks with DuckDB and Iceberg and Glue Catalog? Apparently not yet. If you skip, you could hand wave on Python and then use Athena. But like Athena, I want to do zero infrastructure.
Yeah.
Yep. Let's see. What other? I think there were some other things I wanted to make sure we covered. There are groups successfully doing last mile transformations. Like Netflix gave a talk about, or the Metaflow team gave a talk about like fast data Metaflow, loading tables from S3 at lightning speed with PyArrow and Metaflow S3. So yeah, like Metaflow, for example, is really big on this idea of like last mile data transformations where you use like things within Python to read data directly from S3. And they're apparently getting a lot of mileage out of this. And it's just, this is what it looks like if, let's see, what are these? These are gigabits per second. So this is data. So these are some data load speeds. Anyway, so I wish they had a comparison on Spark and other query engines versus this. But like the promise of speed is there. Yeah. And the practicality, like there are people doing this in enterprise at scale today for like very serious pipelines and having a great time with it. And so I'm really hoping that this becomes more available to the rest of us and I just wasn't able to get it working this time. What else? But yeah, super excited for this because I honestly feel like this absolutely makes the most sense for data scientists. Like these tools here, these are tools that they know and tools with a very
well,
robust like data science ecosystem. And the thing that we ran into head first today was an ecosystem limitation. It's like the Iceberg ecosystem apparently doesn't include like easy reads for DuckDB. And when I look at, okay, here's another thing I wanted to show you. Like I was like, okay, PyIceberg has this Upsert function, and I couldn't get it to work. Does anyone else have an Upsert function that I could try? And the answer was no. Polars and Daft and even AWS Data Wrangler, all of them had append functions, but I didn't see Upsert functions in any of them. Which makes sense because Upsert is an operation which requires you to understand the metadata a bit more, whereas append is just like probably dump a metadata file too. An Upsert would require you to actually maybe read some metadata as well and understand it. So I can see why that's more complicated and why it would not be the first thing to be implemented.
Yeah.
But yeah, it's an ecosystem thing. If the Iceberg ecosystem is young, that's sad because this ecosystem is strong. So if the Iceberg ecosystem could help us use this ecosystem, that would be sweet. And I haven't validated any of this, but people are saying that the Delta Lake ecosystem is more mature. So I assume what that means is maybe there's some better support in client libraries, stuff like that. So I think there's been some confusion. Like people say Delta Lake is not open source, but Iceberg is, but they're both open source. So I think that's something that Databricks is having to push against right now. Convince the world, no, you can use us wherever. It's a little weird to go to use Delta Lake though, because if Glue Catalog has support for it. Like AWS, they just came out with a product called S3 Tables. So it seems to me like AWS is wanting to like bless Iceberg instead of Delta Lake. Maybe the reason they named it S3 Tables was to be generic. So maybe one day they could support other formats. So I see now as I say that. But AWS is clearly going all in on Iceberg in their marketing. They're talking about Iceberg much more. In their docs, you can still see some stuff for Delta Lake as well. So yeah, I would love people who know more than me about all this stuff to get in contact and answer some questions. And maybe you can help me actually make this work. Thanks a ton for joining. Hassam, do you want to say anything before we sign off?
No, thanks to everyone who's watching, who's still here. You can come hang out with us, discuss these things, nerd out over very specific and very general things. And thanks all. Thank you all. Check out our course.
Hassam's going to be leading our next cohort of Python on AWS course starting next Monday, or the Monday after this coming Monday. It's a great course. We get rave reviews. We just really struggle to get the word out. Here's an ad in your face. Now you at least know this thing exists. So
spread the word. Spread the word.
all the stuff we wrestled with today with the authentication and Boto 3 and auto completion and installing stuff, like, and just generally working with AWS. If you know anyone or if you want to get a better foundation, like generally working with AWS and building on it, come take our course. And then in office hours, we can talk about anything. We can talk about open table formats if you want. Cool. Everyone, thanks for coming. Catch you on the next one.
Yeah. Thanks, Eric. See you.